welcome to Learn Live. This is GitHub administration for GitHub Advanced Security. My name is Jose Palafox, and I'm a strategic application security engineer here at GitHub, which is a very fancy sales title. That means I support all of our largest customers here on the West Coast with adopting GitHub Advanced Security. Really excited to share with you all this Learn Live module today. I'm also joined by my best coworker in the world, Dan Shanahan. Dan, you want to introduce yourself?
Oh, shucks. Thanks, Jose. Yeah, so hey, everybody. My name's Dan Shanahan. Much like Jose, my title also has a lot of words in it. I'm a principal field security specialist here at GitHub. Really what that means is I'm kind of the technical counterpart for Jose. I'm here to help out with some of those technical ins and outs of the GitHub Advanced Security platform with our customers, primarily based on the West Coast. And really excited to share some of this really interesting stuff we've got around administration for the GitHub Advanced Security platform. So let's go ahead and jump right into it.
Today, we're going to be covering two modules on the MS Learn Live platform, or the MS Learn platform. You can go ahead and scan these QR codes or follow these links, or if you're watching this retroactively, you may already be on these pages. So wherever you are, you're in the right place. You can follow along here with these learning modules. This conversation today may seem a little blocky because we're going through the learning module as if you were sitting down in front of it and taking it. So if Dan and I show up to do a POC kickoff call or a demo for you, it'll flow a little bit differently than it does today because we're really following the format that the learning module has so that there's video content to go along with that later. But because you are here in the live audience, if you'd like to ask us questions, please use that Q&A function. I'm going to be moderating it when Dan's talking, and Dan's going to be moderating it when I'm talking. And I think there's other moderators that are moderating it constantly. So we're going to have a great time here. There's only 700 of you that have registered. So we're going to be able to answer every single one of those questions. We're really excited to hear from each and every one of you.
Fast typers
no
over
problem.
Actually, real quick, Jose, I want to make a real quick call out. We actually have a lot of really good content on the Microsoft Learn site for GitHub Advanced Security. So we're going to be focusing on two of the modules, but there's other modules there as well with GitHub Advanced Security, specifically one for like code scanning, one for code QL. I encourage you to spend a little bit of time browsing around inside of there and getting a sense for some of that really good, like learning material that we have there. It's fascinating stuff to read through. Sorry, I didn't mean to throw you off there.
No, you're right on the money. I used all of this content to, I guess, skill myself up for our administration certification tests. So, it's what we use internally to train and get our people ramped up. So you've got the best source of information here, and really excited to kind of work through it all with you all today. What we're going to be trying to do, well, we have two sections like we mentioned earlier. So this first section, we're going to try to walk through kind of at a high level, what is GitHub Advanced Security? If you've been watching, build all day today, you'll know that GitHub Advanced Security for Azure DevOps has been announced for public preview, and so much of the stuff we're going to share with you today is also available on Azure DevOps. We're going to focus primarily on the GitHub experience, just because that's already ready and in production and kind of out and something that customers are using. But the new product was just broadly released today and is also going to map very closely to what we share with you today. So we'll go through and describe at a high level what the product does, sort of how we thought about it and came into it. We'll talk about how to enable it as an administrator, and then what to do with the alerts and things that are coming in from the tool once you have it enabled. So I'm really excited to keep moving on this. Dan, you got anything else you want to add?
No, I think you captured it pretty well. I mean, the goal here is to, really get information in the hands of folks who will be handling the care and feeding of GitHub Advanced Security on the GitHub platform, and really kind of understanding some of those management capabilities. Along the way, we'll also address, like the core focus is developer productivity, right? We'll also address a little bit about that as we're kind of working through some of these management capabilities.
So to kind of get us started, let's talk about what's in the tin. What is GitHub Advanced Security? This is a set of features on GitHub that deliver application security functionality to you. And it's kind of got four major components to it. So the first piece is a product called code scanning, which we have our own code scanning engine called CodeQL. So if you hear us say CodeQL or code scanning, what we're talking about here is a static analysis tool that looks for security vulnerabilities in your application's code while it's at rest. So this is kind of a form of white box testing. We know We have your whole source code kind of stored in GitHub or in Azure DevOps, and we can interrogate it for patterns that we know are insecure. So things like the OWASP top 10 or common vulnerability types like SQL injections and things like that. We can model that using our static analysis tool and then search for it through your code base. So that's one component of the product. The second piece, and where we're going to spend a little bit more time in the back half of this session, is secret scanning. Secret scanning is a really cool tool. Basically, we've worked with all of the leading cloud and SaaS vendors in the world and gotten patterns from them that match their API credentials. And then we check for those credentials on every commit to GitHub. So whether you're in a github.com public repository or a private repository on GitHub Enterprise Server, we're going to be monitoring for potential leaks of API tokens. And this is really important because this is the #1 attack vector kind of facing businesses today. People find credentials, which you can imagine is almost like a physical key just laying around the office, and then they're able to go and try it in different locks until they get access to some other service and continue moving through your infrastructure. So this is a really risky thing if we have keys that are leaked and sitting in code at rest. So secret scanning is a tool that helps us find all of those keys. It also stops us from introducing new keys into the code base using a feature called push protection, which we'll spend a good amount of time on in the back half of the third product is an SCA capability. So this is GitHub Dependabot is what it's normally known as. I have to keep moving my mouse, otherwise I'll shut my screen off again. I apologize. So that is our supply chain security tool. Sometimes it's also referred to as software composition analysis or SCA, supply chain security, whatever you want to call it. But basically, we're looking at all of the dependencies that you have for an application, and then comparing that with a list of known vulnerabilities that we store in the GitHub advisory database. And then we're alerting you that maybe you're using an insecure version or maybe a version that's just out of date using this Dependabot tool. So that's our supply chain piece that's also in the product. And then all of the alerts from that get rolled up into an enterprise level view called Security Overview that allows you to triage alerts, and to interact, close alerts, that sort of thing. So those are the 4 kind of product pillars. Like I said, we're going to focus in this first session kind of at a high level of how all this comes together in an experience on GitHub. And then in the second part of this presentation, we'll dig a little bit deeper just on secret scanning. So where are these features available on GitHub? If you're using github.com, the public resource, where you can go and pick up common open source projects, or maybe where you publish your side project, you can use all of these features for free. The only thing that you don't get on public github.com is that security overview view of the world. There are some UI elements, but you don't have the full aggregate. But it's rare that as an individual you're going to have so many projects that you need a big dashboard to aggregate them all. But by and large, we try to offer these projects or features for free to open source developers because it just improves the overall posture of open source security or open source software and securing open source software. So we give all this away. And if you work in an OSPO or you work on any kind of public project, please go play around with this stuff. You can also fork popular projects like OWASP Juice Shop or WebGoats or something like that, and you can run the security tools against those kind of intentionally vulnerable test applications to play around with it. So it's a great way to get familiarized with the product and get your hands dirty. If you're in an enterprise, whether that's Enterprise Server or GitHub Enterprise Cloud, you can still use these features, but they are licensed. And so you would need a GitHub Advanced Security license to do this stuff. Or you can work with Dan and I, and we'll get you a POC license so you can test it out. So
real quick, Jose, let's actually, I want to make sure that we're super clear on maybe demystifying a couple of other points here. We work in application security, and kind of out of that comes acronyms, right? Like we definitely throw a lot of acronyms at folks. And so you may hear us use the term GAS. I just want to be super clear on what exactly we mean by that. That's an acronym for GitHub Advanced Security. It's just kind of like native vernacular for us. We say that all the time. We use it in writing all the time. So if you see GHAS or you hear us say GAS, that's what we mean is the GitHub Advanced Security feature set. And Jose actually called out one other acronym there. It's OSPO, OSPO. And what that is it's the acronym is Open Source Program Office or project office, program office. The idea is it's a body within an organization that that controls and creates guidelines and rules for releasing and consuming open source software within organizations. A lot of enterprises are spinning up this idea of an OSPO, and they're a really good location for interacting with the open source community. So just wanted to make sure everyone was caught up on a couple of those terms. SAST, that'll be another one that'll pop up here in a little bit, static analysis testing. So just throwing that out there, making sure everyone's on the same page as us.
Yeah, and everybody get a spoon out because there's going to be more word soup to sort through. So
right,
we'll be ready. All right, so what we've got here is another acronym, the SDLC, the Software Development Lifecycle, right? And what this is trying to show is sort of how developers do their work day to day. So we have an idea for a project. Maybe we make that as a series of GitHub issues or Azure boards, issues or items, to sort through backlog items, right? So we create this idea of our project, and then we get through writing our code. And once we have our code, we want to start testing it. We've got multiple people collaborating on it with us. As we're adding code, we're doing code reviews. We're doing CI testing. We're doing deployment. So continuous integration testing, continuous deployment process. And then we have some quality assurance and integration testing that we work before we ship the tool. And when people think about application security, generally, they put the security step kind of post quality assurance and integration tests. Basically, we're about to send this thing out the door. Let's just make sure we don't make a mistake. And that's how people kind of approach security, maybe in a classical lens. You'll see tools that scan binaries are really focused at like this last step before the published software artifact goes out into the wild, whether that's an internal deployment or something that you're externally selling to your customers. People put the security step here. And what GitHub Advanced Security is really trying to do is help us integrate the security process much earlier into the software development lifecycle, so that as developers are writing code, they're getting feedback near instantaneously about security issues that they may be introducing. And this does a lot of really positive things for us. The most important thing it does is it makes people more aware of the security vulnerabilities that they are introducing. Because when we kind of shine a light on something that an engineer is working on while they're kind of in the headspace, working on that problem, they're able to very quickly remediate the issue. And that has this benefit of just reducing the backlog of vulnerabilities that build up for security teams to triage. As I'm sure all of you are experienced, your organizations are writing more and more software for more and more automation tasks or for other business logic that you need to support. We're all writing more software, and so as we continue on this path of using software to build our businesses, we have to start thinking about security much earlier. Otherwise, the number of vulnerabilities will just pile up, and we're in this state where we can't even address the backlog anymore. And that's where Dan and I find a lot of organizations, most commonly, is they're in a state where their security team is stressed out about the number of vulnerabilities that are getting thrown over the fence. They don't have a great relationship with their engineering team to be able to remediate all of them. They're constantly bickering maybe about whether or not something is a true positive or a false positive, or is accurate or not. And that isn't helpful to the business. So what this whole product is designed to do is to shift the security awareness early in the process so that everybody knows who's responsible for what and can talk about it and use some of the collaboration tools in GitHub to do their jobs more effectively. Dan, I knew I took up a lot of time there, but would love your feedback on kind of what do you see as the big benefits here?
Yeah, no, you really nailed it, right? Like it's kind of a multi-pronged sort of thing. Like on one hand, if you're able to get results in front of developers early in the process, then this is super beneficial just in a lot of different ways, right? Like you reduce the count of vulnerabilities that are getting released into the wild. You shorten the amount of time that it takes to resolve these vulnerabilities, and that directly translates into like dollars spent, right? That's engineering time that's spent on resolving the problems. But there's another piece of it too, beyond that, like that process of preventing or quickly resolving vulnerabilities. It's also the developer experience too, right? You're going to hear a lot of this from me throughout this conversation, and GitHub as a whole. This is really what we center every aspect and every decision that we make as an organization is how does that impact developers? How does it make developers' lives easier? And When you're able to get things like security testing, which has maybe traditionally lived outside of sort of the developer processes, or maybe it's lived in third-party testing tools, when you're able to bring that into the ecosystem where developers are already familiar with, they're already working in, they're collaborating, they're resolving problems on, which is GitHub, it becomes very compelling. It's a much more easy and seamless sort of experience for developers to be able to interact with those results. In fact, let me actually share my screen. I'm going to grab my screen share from you here, Jose, and I'm going to take a look for the audience here. We'll kind of talk briefly about what this experience looks like from a developer's perspective. I think it's really important to sort of level set on what this looks like for a developer. Helps to kind of connect those dots. So here I am inside of a pull request. Bit of definition, the idea behind a pull request inside of GitHub is effectively developers are able to work on a separate copy of the source code that's stored inside of GitHub, and we call that a branch. So a developer is able to check out a branch, and they're able to modify parts of that branch, build new features, fix a bug, whatever the case may be, but it's a direct copy of that production code. So they build this new feature on this branch, and then they go through this process that we're taking a look at here, which is a pull request. And what that is the process of merging that branch into the main branch or the production code. This allows a lot of developers to be able to work together at the same time. And it also gives us really interesting point, like an inflection point where teams can come together and review the source code being changed, right? This is the pull request review. Typically, it's a human-led sort of engagement, right? We've got experienced engineers commenting on things like code quality, et cetera. Now we're introducing security testing into this process. So in this example, Geek Masher, a gentleman on my team, his real name's Matthew. He's created this new feature, right? A new feature that's going into the main code branch here. You can see during this process, and he's got all of his code. We can, go through this review process. We get a notification along the way, and it says, "Hey, heads up, there's a problem inside of this code." And specifically in this line here, where you're doing this execute query statement, turns out you may have introduced a SQL injection vulnerability. This is interesting, having this feedback at this point, because number one, we still haven't merged this code into the main branch, so we're able to solve this problem. But number two, we're able to tag in other folks. So in this case, you can see Matthew or Geek Masher has reached out to Nick and said, "Hey, Nick, can you give me some extra thoughts on this? What does this mean?" Nick's replied and said, "Yeah, hey, buddy, this actually is a problem. You need to make sure that you resolve this." So from there, Matthew can go in, edit the code, readjust his commit, readjust the code that's involved with that commit, and fix this problem before it actually getting merged into the main code base. There's a lot of other things you can do inside of this UI, and we'll kind of work through that in a little bit here as well. But one last thing that I want to call out is another really interesting capability that's available inside of the pull request is the ability to do things like adding gates. So in this case, we've got a rule on this repository that says, hey, you're not allowed to check code into that main branch. You're not allowed to merge code into the main branch of this repository unless it has passed all of its checks. In this case, we can see that code scanning actually failed the check because we found this vulnerability earlier. And this is a really good sort of toll gate that allows us to pause the process from an administrative or from a compliance level, to pause this process and make sure that the security is taken into consideration as these new features are being built. Basically, Matthew can't include this code into the production code base unless he fixes this vulnerability first.
But what's really important here is that Matthew's only seeing the vulnerability that he introduced in this pull request. And so it's highly targeted. This isn't a big list of every vulnerability we found in the code. It's just saying, hey, Matthew, you introduced this net new one. So you got to fix that because we're not letting this problem get any worse.
Exactly. All right, so we're going to go through a few more examples like that here as we kind of move through the conversation. But what I want to do is jump back over into the slides, and we'll kind of talk about, and we'll maybe shift gears a little bit into more of the administrative perspective of advanced security, right? That's why we're here, is the GitHub administration for advanced security. So we'll go ahead and jump into that conversation topic. So let me see if I can find my spot. Here we are. Okay, so when we think about enabling GitHub Advanced Security, there's a couple of considerations we need to take into mind here. Number one, the flow for enabling this utility looks a little bit different if you're using GitHub Enterprise Server versus GitHub Enterprise Cloud. So if we take a look at like the steps, right, the mechanics behind actually turning this on for Enterprise Cloud, it's pretty straightforward. When you provision a license for GitHub Advanced Security, the entitlement, right, the rights to use this software is basically automatically available to you, and you can go directly into your enterprise configuration or your organizational configuration, and you can turn on these services. You'll see a big enable all button. I'll show you what that looks like here in a few moments, and you can actually turn it on in that manner. Now, with Enterprise Server, the steps are a little bit different. The idea behind Enterprise Server is it's a basically a GitHub in a box, right? We provide an appliance to teams. They're able to manage that environment inside of their own environment. They host their own version of GitHub internally. With that, the steps are a little bit different. We need to actually provide a brand new license file to your enterprise administrator. The enterprise administrator will then go in and apply that license to the GitHub instance. And then from there, there's going to be a couple of different services that actually need to be turned on. You'll see these checkboxes inside of the administrative UI in GitHub. Check the boxes, and then really important note here, what we're doing here is we're enabling certain services on the appliance. That requires a service restart. So it's a very important note there that there will be a brief amount of downtime as the GitHub services are being restarted. I'm going to take a moment. I'm going to share what kind of that administrative enablement thing looks like. But I think before we do that, I want to talk a little bit more about sort of the administration and management of some of the other kind of other features and capabilities that are in there, including alerts. So when we're thinking about alerts within the GitHub platform, what I mean by alerts is outputs from these security testing tools, right? So as Jose called out, we have kind of 3 core pillars of security testing capabilities within advanced security. Each of those pillars or each of those types of tools output some sort of finding, right? It comes out either as a code scanning alert or a secret scanning alert, or maybe a notification from Dependabot that there's a vulnerable package being used. We take a pretty kind of open stance here at GitHub. The idea is, in general, with alerts from code scanning and Dependabot, we want to allow folks with kind of basic write access to the repository, folks that are authenticated into GitHub, authenticated into your environment. We want them to be able to have visibility to these alerts. We want to be able to provide kind of a culture of openness inside of the environment that allows teams to have the tools that they need to fix problems that are being identified. Now, there's an exception to that, and that exception is with secret scanning alerts. Secret scanning alerts are actually much more locked down. We don't, the only folks within GitHub that'll have access to a secret scanning alert are going to be either the person who committed the token themselves or repository and organizational administrators. The one thing that we don't want to do is create kind of a centralized sort of database of API tokens and credentials that are found within your environment. We don't want to make it super easy for folks to be able to get access to that. So that's locked down a little bit more, but those rights are configurable and you can control that. There's also this other idea that exists within GitHub, and it's or within GitHub Advanced Security, and it's this idea of a security manager role. And this is really important for organizations that want to be able to fine tune the rights of folks who need to see alerts and who need to configure settings within GitHub Advanced Security. The security manager role, the idea behind it, is a role that provides access to teams or to individual members within your GitHub environment, provides access for them to be able to configure these settings at the repository and organizational level, and also grants them access to be able to see the alerts. And so like the type of person that you would give this right to would be somebody who is maybe an AppSec team manager, right? So you have a team of folks who are in charge of caring for and feeding application security testing tools. It's a great person that you would want to give this type of right to. It restricts their rights on the GitHub platform to just those security utilities. They can't do things like delete organizations. They can only turn on and off those security features. So it's like a quasi-admin role. This table that you're seeing is kind of a breakdown of those rights for each of those different groups. But thinking about accessing alerts, we'll set that aside for a moment. That's kind of the ability to view the alerts that are provided by GitHub Advanced Security after the tooling's been enabled. But then there's also this question of how do I restrict or provide access to these utilities at like an organizational level? What kind of knobs and buttons are available for me to tune that configuration? How can I restrict maybe specific organizations from being able to use this? So if you think about an enterprise, a GitHub enterprise, we've got multiple organizations inside of there. It's entirely possible for, say, an AppSec team to not want every organization to have access to advanced security because maybe they don't have enough licenses to be able to cover all of the team members in that other org. Or maybe it's a new acquisition or a brand new organization that's been spun up. You can restrict that access in that manner. And that's exactly what this looks like, right? So if you go into your enterprise configurations, and I'll walk through this all in a few moments. I know I'm kind of throwing a lot of buttons and screens at you here in text, but if you go into the enterprise configuration, you have the ability to restrict it down to specific organizations, or like tell specific organizations that they're not able to access these utilities. The last piece that I think is really important here. So up to this point, we've talked about providing access rights to view alerts and manage and turn on and off the services. We've talked about the ability to turn off and enable the service at the organizational level and within your enterprise as well. And the last piece is actually dealing with and understanding where to get access to the information that this tooling is providing you. Primarily done in 3 ways inside of the GitHub platform. I'm going to share with you all the tooling that we have that's called the security overview. Remember, there's 3 capabilities, and then we have security overview. That's sort of the layer that allows us to report on and understand sort of the posture of our program. I'll share that with you here in a few moments. It'll be part of this demo that we're going to jump into next. But do know that beyond just the security overview, and we get this question a lot from our customers, is how do I extract the information back out of GitHub, right? Maybe I have an external SIM or a security event management tool, or maybe I have a vulnerability management tool, or maybe just a plain reporting platform that I want to stick all of my data in, like Power BI, right? There's some very capable programmatic options that are available to you. And those look like kind of 2 main things. Number one is an API. So within our REST API, you have the ability to extract all this information. You can extract all the configuration information. You can pull down all the different alerts. There's boundless amounts of information available for you to grab out of the API. The other primary way that folks extract information is something that's called a webhook. And the idea behind a webhook is it's effectively an event-driven JSON payload that's sent off to some sort of processing system every time an event happens, right? Anytime a code scanning alert shows up or gets closed or whatever the case may be. Webhooks are really powerful. They contain a lot of context about what happened in that alert, who did it, when they did it, what action they specifically took, but it also contains lots of other information about like the repository, organization, et cetera. It allows you to do some really interesting event-driven sort of workflows based off of that. So let's take a look at this. I'm going to go ahead and share my screen again. We're going to jump right into demo mode.
While Dan's pulling that up, I think one thing to think about, is, and we'll show you this live too, but you can extract maybe when a secret is leaked, and you could correlate a top 10 list of who leaks the most credentials in a SIM platform like Sentinel, and use the pivots in either Power BI or Sentinel to identify maybe groups that need AppSec training, or that would benefit from a conversation about how to use something like Azure Secret Store to store credentials more safely. So some of these other business intelligence tools or analytics tools can do a lot of interesting stuff with the data, and we make it really easy to pull out of there. Dan and I have worked on a number of these integrations together.
Yeah. Absolutely. Okay, so let's talk about actually enabling this service. So it's important to know when we're thinking about, like, one way that I find that helps me kind of wrap my mind around like enablement strategies at scale for advanced security is to remember that all of these features are technically, like at the most basic level, enabled at the repository. All of these configurations live at the repository level, but we add abstractions to that at the organizational level and at the enterprise level, right? So you got bunches of repositories that are all part of an org, bunches of orgs that can be part of an enterprise. Each of these layers has a layer of abstraction that you can say, enable all, right? Like just click all those, 10,000 buttons for me. Let's take a look at this at kind of each layer. So I'm at the repository level here. I'm at that base level. Underneath the settings for this repository, you can go to code security and analysis. As Jose and I were kind of working through this presentation, we realized that we say code security and analysis probably 100 times in this presentation. So get ready for it. It'll be drilled in there for you. Underneath code security and analysis, you'll see this advanced security button, right? You can see it's enabled right now because the only option I have is disable. This means count the licenses. This means tell me, enable this service, enable these capabilities on this repository. Underneath this, you've got code scanning. Code scanning you can enable with just clicking the button. Here you can choose to set up and get either a default or an advanced setup, secret scanning, Dependabot, et cetera. All those configuration options are available at the repository level. Now, if we zoom up one level, I'm going up to the organization now. So that repository was part of the Octodemo org. If I go into the security settings underneath my settings tab here, code security and analysis, see that exact same option. Instead of saying enable now, they say enable all. This implies we're turning on this service for all of the repositories that are part of this organization. So here we can turn on GitHub Advanced Security. So saying, hey, make these things available for our repos. We can, again, turn on code scanning for all of our repos. We can turn on secret scanning, Dependabot, et cetera. And then finally, let's take a look at this from the enterprise level. If I go back up to, I clicked on my icon up here for my user account. If you go to your enterprises, this is where you can manage the different enterprises that you're a member of if you have those rights. One thing of note, you've got to be an enterprise admin in order to get access to a lot of these settings. So you may not see this in your environment. Talk to your enterprise admin. But again, we go to settings and then code security and analysis. This is how we turn this on for all of the organizations or all of the repositories in our entire enterprise, which can be a significant amount of repositories that are there. I also talked about this idea of restricting specific organizations from being able to access these utilities. That's handled under the policies. These are policies that we create. If we click on code security and analysis under the policies, this is where we can restrict which organizations have access. So in this case, I've got Burrito Party 2. This one actually does not have advanced security enabled. So that means any repository under Burrito Party 2 cannot turn this service on. These are licenses that are not being counted against our license count. We have a lot of other configuration options in here. They're a little bit outside of the scope of this conversation, but just so you know, that's where, this is where a lot of these settings would exist. Even things like configuring custom patterns for secret scanning. We'll get into this in a little bit here, but this is where you would handle this at the enterprise level.
It seems like obvious, like, hey, there's a spot to turn on your tools, but it's really powerful that there's no third-party platform that you've got to wire all this stuff together. From an integration standpoint, we just showed you what a rollout looks like. You poke a button, and now you got it, which is really cool. It's a big aha moment a lot of times when we're showing people how to set the product up. They'll say, how many weeks do we need to POC? And we'll say, like, maybe an afternoon. So it's really nice to be able to get this stuff spun out quickly.
Yeah. I mean, when you think about like that whole concept of, our focus on developers and our focus on making developers' lives super easy, right? Now you can start to think about your security tooling kind of falling into that same kind of concept, right? Like you can manage all of your GitHub configuration for your application security testing as, say, code if you wanted to. All of these configurations could live as, code configurations. And we see many of our enterprises that we work with doing that, right? Like you manage these configurations as like config files or as scripts and manage it that way. Alternatively, you can go in and, actually click buttons inside of the UI. So there's a lot of flexibility from a management perspective. Okay, so that was kind of that first part of that discussion that I just shared, right? Like we're talking about the administration of it. We're talking about turning on the features. But now let's shift gears a little bit and let's take a look at this from a we'll put on the hat of a security engineer who needs to get a sense for how many vulnerabilities I have inside of my environment.
And
Again,
imagine
same
you're
layout
running like
happens here.
5 minutes behind schedule.
Yeah, like in this wild world. Yeah. So in that situation, that was good. I like that. Hint taken. um, so what I did was I clicked on the security overview. This is the security overview. The security overview, we're looking at it from the organizational level. We've also got this in the enterprise level. This is a fresh release. This is something that just came out, so you can see these same results across all of your organizations as well. This gets really powerful. We can answer questions like, how many different critical alerts do I have inside of my entire environment, right? Like, what's that risk posture? We can also answer questions under this coverage page here. How many of my repositories have secret scanning enabled? You know, understanding the coverage of your AppSec program is really important for a lot of organizations. This is where you answer that question. You can introduce some really interesting filtering here as well. So you could do something like sort by topic, right? Topic, we'll say backend. In this case, I can filter down to topic is backend, and that allows me to only see repositories that have that particular topic assigned to them. And I can apply that to the risk and coverage as well. All of the alerts, those show up in the alerts page here. So all of our Dependabot alerts, all of those software composition analysis, open source alerts will show up here. Code scanning from all of our repos, even bubbled up again to the enterprise. These will all be available to you, and secret scanning as well. All right, with that, I'm going to go ahead and stop the screen share here. Jose, I believe it goes back to you, if I'm not mistaken.
We're figuring this out together. Do you have can you pull the screen back up, or do I need to share again?
Share that for you. Yes, sir, you bet.
Sorry, I think if we break the chain of handing it back and forth, we lose our place in the slides, but we're doing great right now.
Get you over to where you are here. So talked about this. Sorry, everybody. Features and alerts. We talked about that. Talked about webhooks. Here we are. All right. So, oh yeah, this is where we get everybody else involved. It's everybody else's turn.
Yeah, you haven't given us any Q&A yet, but now you have to answer this question, or at least think about it.
Yep. Just seeing how close of attention you've been paying.
Which GitHub Advanced Security feature is not available on public repositories? This was during my long spiel right at the beginning. You can scan the QR code. You can just think about it. You can paste it into the Q&A. You can say it out loud to yourself. All right, let's. You ready for the big reveal, Dan? What's your guess?
1 second. Let's give it just a few moments to see if we get a few votes to come in here, Jose. We haven't received any votes quite yet. We'll see if anybody. Here we go. Okay, so we got a few in now. So we've got. Let's see here, 2 votes for. 3 votes for security overview, 1 for code scanning, and 1 for secret scanning. They're still coming in, but it looks like we're seeing a pretty clear winner at 62% for security overview, or B.
Let's find out.
It's B. We got it. I realized we didn't tell people that we were going to do this knowledge check before going into this, so heads up, everybody, there's going to be a few more.
There's going to be a few more. We can do one more before we move on to the next half of the presentation here. One more question for you. Where can you enable GitHub Advanced Security for private and internal repositories in an organization? And I think we hammered on this one pretty good. It's something we're going to say a lot of times. So this one should be a home run. I think we'll get 100% on this one. What do you think, Dan?
I sure hope so. All right, let's see here. We got the results coming in so far. I don't want to taint the results by saying what people are voting for. Suffice it to say, this one's at actually the same percentage. So it was 55% have voted for C, the organization's code and security settings. Now it's at 63%. So I think in general, the message was received. Code security and analysis.
But here's the thing. It was a little bit of a trick question, because as of a couple of weeks ago, we got a new ship that includes allowing you to set this up through the organization security tab. So whether you pick C or B, you're still right. We make it very easy to enable all of these features. Everyone's a winner. It's an inverse Monty Don, or not Monty Don. What's that guy's name? Monty Hall. That's it.
Yeah, exactly. Yeah.
Monty Don's a European gardener that I really like, so you can check him out later.
Okay, gotcha. Yeah, I wasn't following you until the Monty Hall problem.
Yeah, there we go. All right, so there's more resources available for you. Feel free to scan this QR code and it will take you to more training and white papers, documentation links, things like that. So there's a whole bunch of stuff that we've talked about that is better documented. If you want to double click on any of these, feel free to jot this down, or we can paste this link again into the chat or something for you. But there's a lot more resources available for you to keep learning about GitHub Advanced Security. And we are going to move on to configuring and using secret scanning in your GitHub repository. So imagine we've just launched that video again. You're back at Build. Welcome. Thanks for coming to session 2.
Welcome to Build.
Configuring.
I'm Dan.
Yeah, welcome to Build. All right. Hopefully they can make a cut out of that. All right. So in this module, unlike the first one, we're going to focus on a single feature, right? And in this case, we want to zero in on secret scanning. Secret scanning is a really cool product, and so we're going to cover, what it is, how it works, how do you configure it, and how do you use the alerts. Some of the things like dismissing the alerts, which we'll talk about later, also apply to code scanning and also apply to functions and dependent bots. So it's a very consistent user experience. So this is kind of a sampler of one of the 3 products, and you can kind of squint and imagine how it'll work for the other ones. And as you go through the labs, you'll see how they're all pretty consistent. But this one's a really fun one because it's straightforward. So what is secret scanning? Basically, we have a open source project that we took called HyperCredScan, which is a regex scanning engine or a pattern matching engine. And then we have a library of regex patterns that we've gone and collaborated with all of the leading SaaS companies and cloud companies in the world to work with them and understand, what does your API token look like? How do you generate it? Is there maybe a prefix that starts your API token? So for GitHub, a lot of times it's GHC or GHA or GHE, whatever the acronym is for the beginning of the token, depending on what you're generating it for. There's a different acronym, and then it's followed by an underscore. And then we may want to learn things like, how long is it? How many characters? And what does that character set look like? And sometimes providers have things like embedded checksums in the token that help us to better target only those tokens and really drive down the number of alerts we're generating. One of the key value props of this whole product and why we're able to introduce security tooling earlier in the process, because we've worked tirelessly on driving down the false positive rate. So for some of our token pattern types, we know within 1% or less that we're finding real tokens from that generated SaaS service. We're really accurate with it. So our average for the product overall is above 90%, and then for about half the tokens, they're less than 1%. So it's a very accurate engine for us. But we run that set of patterns every single time that a developer contributes code to the server or to GitHub.com or GitHub Enterprise Cloud. So it's a server-side scan. There's no client-side configuration. This isn't done as like an IDE plugin that you have to keep up to date. It's not a distributed set of secrets that you're scanning for on everyone's laptop. This is all done centrally, and that's how that administration view that we showed you earlier is able to be set up so quickly, is because it's a gate before we write the push to the repository. We're going to run this scan. We have a really interesting capability here where we can actually prevent pushes from coming into the repository if they contain something that looks like a secret. So if we notice that you've accidentally contributed your Azure Blob Storage key, rather than having you push it and then giving you an alert, we're going to take a more proactive stance and say, hey, we noticed you tried to push this and it contains, an Azure key in it. You really don't want to do that because it's going to cause you a bunch of hours of work and security incident paperwork and stuff to go do. It's better if you just go put this into Vault like you're supposed to, fix the commit history locally, and then re-push it, because we'll save you a bunch of time if you follow the alert that way. So that's really the way that we like to deploy secret scanning, is in this proactive mode. When we initially turn it on, we also do a historical scan of every commit in your commit history for the project. So this could be tens of thousands, hundreds of thousands of commits. We're going through and looking for potentially leaked API credentials. And there we're trying to find, are there keys that are just sitting around that are maybe still valid or that you should be aware of? Are there, assets that you're looking for that are already leaked? Maybe they're leaked publicly. We'll help you get a baseline of what your code looks like. And again, as we talked a little bit in the previous section, you can use some of that information to target specific teams that need training on how to properly store secrets or how to deal with certificates, or just handle common scenarios that that maybe they're not following policy correctly, and you want to go have a conversation with them about that. So this will give you that historical insight, and then the prevention will prevent the problem from getting any worse. So this is kind of a view of what the credentials look like when they're in that security overview view, right? And Dan showed you this earlier. You have, again, the same kind of filtering and search capabilities to drill down maybe by the name of the API token, or you could drill down based on the provider of the token, or maybe files that it's located in, specific repositories. There's a bunch of stuff that you can use to pivot the data in and kind of drill down to see the view that you want. You can also take bulk actions by checking multiple checkboxes here and selecting to close these or to do other things with them. So this is kind of what they look like when they come into the UI. There's also an IDE experience when a developer accidentally pushes that token, where they'll get a standard out in the IDE as an error message that Dan will show you a little bit later. When we look at where secret scanning is available, it's on everywhere on github.com. Whether or not you want it to be on, we're scanning for it. And that's a proactive posture that we have, because we want to help all of these SaaS providers maintain their own account security with you as their customer, right? If they find that your token is leaked somewhere on github.com, we actually notify them that, hey, on a public GitHub instance, we found a key that looks like yours. You think you should go check this out, right? And if you have ever leaked an AWS key, you'll know that in a couple minutes of leaking it on github.com, you'll get an email from Amazon saying, hey, we've quarantined your account, and you need to go fix this token. You've got a problem out there. Your root token's floating around somewhere. So that whole process is built through these notifications that we send the SaaS vendors when we find tokens on github.com. Now, if you're a GitHub Enterprise customer, whether that's server or enterprise cloud, we're not scanning your private repositories and telling anybody about it. This is strictly for public repos on GitHub, again, to just improve the overall posture and security of the internet and github.com. You can choose to turn secret scanning on public repositories, and that will give you that dashboard view so that you start seeing the alerts. So if you go and enable it on a public repository, you will get a slightly enhanced experience that you're opting into. And then on private repositories and internal repositories, you go through the motions that we shared earlier to enable it, and you can turn it on internally using a GitHub Advanced Security license.
Cool. So let's kind of breeze through this concept of enabling secret scanning. Suffice it to say, and we've already kind of shared what these screens look like. Suffice it to say, it's really easy to turn on secret scanning inside of the environment. I mean, like, it's quite literally 2 button clicks at the enterprise level. You choose to enable advanced security. You choose to turn on secret scanning for the environment. Then you click a button to turn on push protection. It's running at that point. It's doing exactly what it does. So for example, this is kind of what it looks like. There's the enable button inside of there. It's very self-explanatory, and it's really straightforward as far as that actual process of turning it on. I also shared a little bit earlier that screen inside of the enterprise configuration where you're able to turn on the secret scanning options, but also under policies, you can turn on and configure those custom secrets that you're interested in spotting and identifying for your organization. I'm going to pause on walking through that demo. Maybe we can kind of briefly touch on it after we get through this next part, but we are running a little bit short on time. So Jose, do you want to kind of keep working through this whole use secret scanning section here and understanding kind of the output from that? Continue our conversation.
Thanks for monitoring the clock there. Sorry, I got back into casual conversation mode. So let's talk about using secret scanning. So sorry we shut the demo a little bit short there, but imagine you just click that enable all button and now you're proactively scanning tokens. If you find an alert that's made it past push protection that's coming in, you want to take that pretty seriously, because as soon as the credential is available inside your enterprise, it can start creating problems for you. So you may initially think like, hey, this is a private repo that I've leaked it in, and only me and my 5 team members, even have access to it. But it's really important to take those seriously. I mean, one of your teammates could potentially impersonate you. They could take your API credential and then start doing things in the business as you. Worst case scenario is somebody gets access to some part of the source control management system and is able to maybe fork that project and then scan that and get elevated access from there. So it can also just be kind of laying around, providing lateral access in the organization when somebody's compromised the SCM. So if you get an alert, you want to go rotate that credential. It's just really important that you kind of stop what you're doing and go, okay, I gotta go figure out, is this a production key? What has to happen for me to rotate it? Is it just my key and I can quickly invalidate it and get back to business? But remediation is the only thing you can really do. What you don't want to do is delete the commit, repush, and then pretend that solved the problem, because all of that secret material is still in the commit history. So it is still effectively leaked in the platform. When you see the alert come in, you're going to have the option to revoke, say that the secret's been revoked, which is kind of your remediated state. You can also say, hey, this is a false positive. I don't think this is a real key. This is just a random hash that was in my code. Ignore this, right? Or you could say, yeah, it is a real key, but I've intentionally leaked this and disabled it already because it's part of my test suite or something. This view or this screenshot is a little bit dated. Now, when you select one of these options, you'll get a little drop down to also be able to add your own comments. So you can explain why you're taking the particular action. But this lets you triage the issues really quickly. They do come in. I forgot to mention this in the beginning, but all of the features we've discussed so far can also be utilized by you for custom secrets. So if you have internal API services that maybe are never going to be a part of the GitHub secret scanning program, like all of these SaaS vendors, you can still scan for those API credentials, using custom patterns. You can also look for things that maybe have lower confidence rates in their findings. So something like a social security number might be something you're interested in finding in a particular repository, but wouldn't be the sort of search that we would want to do on the whole enterprise instance. And so if you have certain custom searches or certain regex patterns that you want to scan for, you can add those to the tool. You can also introduce those as push protection patterns, so you can block people from contributing those. And we'll show you that in a demo here in a second. Again, if you want to enable any of this, it's on the code security and analysis page. You've seen this slide 5 times by now. You're pro at it. All right, so if you want to add a custom pattern, and Dan's going to get through this a little bit more hands-on. Actually, Dan, do you want to just jump into it now?
Yeah, absolutely.
It's probably better.
Yeah, no, fair enough. Yeah, so we'll kind of focus on, so I'm going to go ahead and grab the screen share here. And what we're going to do in this demo is a couple of things. So number one, we're going to create a custom pattern. But on top of that, I want to make sure, there was a question actually in chat from Justin. He asked, what kind of availability is there to do things like bypass maybe an alert from secret scanning so that the code can continue to be pushed to the repository? I'll actually walk you through that. I'll give you a demo of what that looks like. So let's see here. So we're back here in our demo organization. What I want to show is kind of like the alert UI as a whole, right? So at that organizational level, if I take a look at the secret scanning results that are in there, you got a lot of filtering capabilities that are available to you. And again, all this information is just available as webhooks or API calls. But I'm going to filter down to a GitHub personal access token. You'll see that list. There were quite a few different patterns that we find by default out of the box. Basically any kind of like third-party API or service that you're going to interact with, we've already got a relationship with these folks and we've already built patterns for that. But it doesn't take much work for us to add new things as well. So let's take a look at this example here. So this is inside of the 15 Miriam's repository. So Miriam is a product manager here at GitHub. She has checked in a personal access token from GitHub. And of note, what you'll see here at the top is that the secret is in fact inactive on GitHub. So we have the ability to do basic validation of some token types, GitHub being one of them. What's happening is we're querying the GitHub APIs and we're saying, hey, is this a live token? The idea being to help us kind of understand the risk. This one's alive or this one's inactive, but if it were alive, that'd be something we'd really need to deal with immediately. We'll get some remediation steps, some information about where that token was. Here's kind of a snapshot of the code where it was inside of this file, action.yaml. And then this is when it was actually introduced. But an important note here is this bottom section. This is our audit trail. This is where we track the events of this alert. The alert will stick around forever. This alert will always be here. The state of the alert may change. It may change from, Miriam bypassed push protection. It may be that if I were to go in here and mark this as like revoked, it would show itself as being closed, and it'll show that I made this action at the specific time that I make it. So you've got a very clear audit trail of the history of these alerts. Let's take a look at the configuration for custom patterns. So I'm going to go back to my settings and say it all together. Code security and analysis. This is where we configure our custom patterns for an organizational level. I scrolled down a little bit on the screen, and here I can just click new pattern. I'm going to give this a name. We'll just call this test 4. And then I've got a regex pattern that I use all the time. It's just test with a prepended test. And then it's 3 characters, three numeric characters. Test _ 1, 2, 3. This is a really important aspect. We have to evaluate this query for it. We have to try this pattern to see if it's going to match anything. So in this case, I got test 1, 2, 3. That works. But if I do not test 1, 2, 3, we can see that that doesn't match that pattern. It's not going to flag an alert. From there, I can save it and dry run it. The dry run, the idea here is that we want to test this in our environment, see if we're going to get any results that come back out before we deploy it in bulk to prevent like overly greedy regex. Last thing, let's go ahead and actually walk through this process of introducing
and there was a question here about what's searched for and whether or not, like, if a list of passwords was in a binary object, like how would that be handled in the repository, or if it's in specific files. Could you talk a little bit about like where all this is happening?
Great question. So we have visibility to everything inside of the repository that's ASCII text. So if inside of, say, a compiled object like a Java binary file, right, like a war file, we will actually be able to find tokens inside of there. We have a hard time displaying like where it is in the context of a line of code because it's compiled, but we do have access to anything that is ASCII text. It also allows us to get visibility to things like GitHub issues. So if somebody puts in text inside of an issue and says, hey, use this key instead, we'll be able to flag on that as well. So anything ASCII inside of the repo, we'll flag on. Anything that's part of your Git repository, tracked by Git as it's being pushed up to GitHub, we'll be able to prevent from being written into the repository. All right, so let's talk about this whole process of push protection. I'll be real quick on here. So I'm going to open up a file inside of my repo. One thing to note, I'm doing this in the GitHub UI, but this experience is going to be the same whether you're using GitHub or your IDE or Vim or Emacs. It doesn't really matter. It will look very similar. So here I'm just going to put a test string, right? And then I'm actually going to paste in my GitHub token in here. Now what I'm going to do is try to commit this, and I'm saying commit this to a new branch. When I actually do this, you'll see that I get blocked by GitHub, and it says, whoa, heads up, buddy. Take a moment. It looks like there's token in here. Do you want to allow this? And I can choose to say, hey, it's used in text or test, or I'll fix it later, right? I can add this bypass process and allow the secret. I'm not going to in this case, but do know that there's kind of a break glass option available there.
Also, those 2 links that you saw, there was the line link, but there was 2 other links there. Those are both configurable, so you can use that to point somebody to documentation about how they should properly store secret material in the future. So, you could imagine an internal wiki page that directs them to use Azure Secret Vault.
All right, so let's go ahead. We're just about out of time. Let's jump into just a quick summary, right? Things we've covered: GitHub Advanced Security, enabling these services, turning on and configuring some of the capabilities of GitHub Advanced Security, and then finally we went into a little bit of a deeper dive on secret scanning, turning that on inside of your environment and really getting a sense for how this works. Couple of resources are available to you as well. I know that there were a few links that were shared in the chat. I encourage you to read those resources and spend a little bit of time actually going through and taking exactly these same courses on the Learn Live program. With that, thank you so much, everybody, for spending time with us today. It was a really fun experience being able to share this information with you. happy to offer any kind of help that I can in this space.
If you're on the West Coast and you'd like to see more about this, you'll get Dan and I. Otherwise, you'll get one of our amazing coworkers to come and talk to you more about this. But we'd really encourage you to take the learn sessions and reach out. Thanks so much for spending an hour with us.
Yeah, thank you, everybody.